Hello, hi everyone. Welcome to this online video classes. This is Dr. U. Raghavinder, Assistant Professor of Chemistry, MVS Government Degree and PG College, Mahabub Nagar, Telangana. In this video, I would like to explain about the heterocyclic compounds. That is, in this video, I want to go part 1 of heterocyclic compound. Okay, fine. Next. What are the list of contents I would like to explain in this video? The list of contents are: the first one is introduction, next is classification as well as nomenclature of heterocyclic compounds. That is, in this video, I would like to explain the introduction, classification, and nomenclature of heterocyclic compounds. Okay, fine. Next, introduction. First one is introduction. Generally, hydrocarbons are classified into two types. Here, the hydrocarbon means these are the basic organic compounds which have carbon and hydrogen atom. These hydrocarbons are classified into two types. Based on the arrangement of the carbon atoms in the hydrocarbon chain. Based on the arrangement of carbon atoms in the hydrocarbon chain, hydrocarbons classified into two types. They are, the first one is acyclic compounds. The first one is acyclic compounds. These acyclic compounds also known as open chain hydrocarbons. That is, acyclic compounds are nothing but the hydrocarbons in which all the carbon atoms are arranged in a normal straight chain considered as acyclic hydrocarbons or open chain hydrocarbons. What are the examples for acyclic hydrocarbons? The examples for acyclic hydrocarbons are generally all the open chain aliphatic compounds. Aliphatic may be in open chain or they may be in closed chain. But here the all the open chain aliphatic compounds, all open chain aliphatic hydrocarbons are generally example to the acyclic hydrocarbons. Here aliphatic open chain aliphatic hydrocarbons generally classified into two types. They are further classified into two types. They may be aliphatic compounds, may be open chain aliphatic compounds, may be saturated aliphatic compounds, or they may be unsaturated aliphatic compounds. Here, saturation or unsaturation of the aliphatic compound generally depends on the carbon valency. Generally, carbon shows tetravalency. If the tetravalency of the carbon is satisfied by 4 atoms or 4 groups, then the compound generally known as saturated compound. That is, in saturated compound, the compound contains only single bonds. The best example for saturated hydrocarbons or saturated aliphatic compounds are alkanes. For example, methane, ethane, etc. Anyone. In the case of unsaturated aliphatic compounds, the compound generally contains multiple bonds within the or in between the carbon atoms. That is, the carbons atoms may contain multiple bonds instead of containing single bond. That is, the multiple bonds means sigma bond along with the 5 bonds. It may be one 5 bond or it may be 2 5 bonds. That is, the best example for unsaturated aliphatic compounds is alkenes and alkynes. In the case of alkenes, these are one type of open chain unsaturated aliphatic compounds which contains carbon double bonds. They have carbon double bonds, generally known as alkenes. Here in the double bond, one is sigma bond, one is pi bond. For example, ethylene or propene or propylene, etc. In the case of alkynes, that is the alkynes also example for unsaturated aliphatic compounds, that is unsaturated open chain aliphatic hydrocarbons. In the case of alkynes, the compound contains carbon carbon triple bonds. Here in the triple bond, one is sigma bond, the other two are pi bonds. The example for alkynes is, the best one is acetylene, propane, etc. Okay, this is about the all open chain aliphatic compounds, which are example for acyclic hydrocarbons. Okay, fine. Next, the second classification of hydrocarbon is cyclic compounds. The first one is acyclic compound. In acyclic compound, they further classified into two types. They are saturated or unsaturated. The best example are aliphatic compounds. Aliphatic compounds are saturated and unsaturated. In the case of saturated, alkanes. In the case of unsaturated, alkenes and alkynes. The second classification of hydrocarbons is cyclic compounds, or these are also known as closed chain hydrocarbons. In these cyclic compounds, in these hydrocarbons, all the carbon atoms generally arranged in a cyclic manner to form ring-like structures. This generally known as closed chain hydrocarbons or cyclic compounds. These cyclic compounds further classified into two types. There are also two types. The first one is homocyclic compounds. These are also known as carbocyclic compounds. Carbocyclic or homocyclic compounds. In homocyclic or carbocyclic compounds, all the atoms in the ring are same, that is they are only carbon atoms. If the cyclic compound contains only carbon atoms in the ring structure, then those called as sorry, called as homocyclic or carbocyclic compounds. These homocyclic compounds further classified into two types. They classified into two types. They may be alicyclic compound or they may be aromatic compounds. In the case of alicyclic compounds means these are one type of homocyclic compounds which have aliphatic nature. The best example for alicyclic compounds are cycloalkanes, cycloalkenes, cycloalkynes. Okay. In the case of aromatic compounds, that is, the aromatic compounds are one type of carbocyclic compounds in which all the atoms are carbons, and these aromatic compounds generally have planar structure, conjugated double bonds, as well as they follow Huckel rule, that is 4n plus 2 5 electron rule. So these are aromatic compounds. Aromatic compounds have planar structure, conjugated pi bonds, and also obeys the Huckel rule, that is 4n plus 2 pi electron rule. Huckel rule is nothing but 4n plus 2 pi rule. These aromatic compounds further classified into two types. They may be benzenide compounds or they may be non-benzenide compounds. In the case of benzenide compounds are nothing but these are one type of aromatic compounds which have iron rings in the cycle. They have iron rings in the cycle. Those called as benzenide compounds. That is, the iron ring may be benzene or they may be naphthalene or it may be anthracene. In the case of non-benzenide compounds, that is, benzenide compounds mainly contains benzene rings in the cycle. In the case of non-benzenide compounds, These are one type of aromatic compounds. They shows aromatic nature, but they don't have any benzene rings in the cycle. So these called as non-benzenide compounds. They have planar structure. They shows aromaticity. That is, they obey Hooke's rule, but they don't have any benzene-like structures. So they call as non-benzenide compounds. For example, cyclopentadienyl anion, propylene cation, sorry, it is cation, propylene cation, not action, cation. It is propylene cation or cyclopentadienyl anion. These are example for non-benzenide aromatic compounds. Okay, fine. Next one is heterocyclic compounds. That is, the cyclic compounds classified into two types. One is homocyclic or carbocyclic. The second one is heterocyclic compounds. In homocyclic compound, they may be alicyclic or aromatic. In aromatic, they may be benzenide or non-benzenide. Here, the other cyclic compound is heterocyclic compound. Heterocyclic compounds mean these are one type of cyclic compounds which have one or more than one heteroatoms along with the carbon atoms in the cyclic structure. That is, the heterocyclic compounds contain one or more than one heteroatoms along with the carbon atom in the carbon chain or cycle. Here, the heteroatoms may be oxygen, nitrogen, sulfur, or it may be phosphorus or boron, anyone. Okay, if you observe the examples for heterocyclic compounds, all these are the example for heterocyclic compounds. The first one is pyrrole. It is pyrrolidine, imidazole, thiazole, thiophene, thiolane, furan, tetrahydrofuran, pyridine, piperidine, pyrimidine, pyrazine, azafine, 1,4 diazepine, 4H, phyran, tetrahydropyran, indole, quinoline, isoquinoline, chroman, furin, pteridine. These are examples for heterocyclic compounds. Okay, fine. Next, if you summarize the classification of hydrocarbons, this chart generally gives information about the classification of or classification chart of hydrocarbons. Here, the first one, that is hydrocarbons, classified into two types based on the arrangement of carbon atom. They may be a cyclic, or this is also known as open chain hydrocarbons. They may be cyclic or closed chain hydrocarbons. These acyclic or open chain hydrocarbons further classified into two types. They may be saturated or they may be unsaturated. In the case of saturated, the examples are alkanes. In the case of unsaturated, they may be alkenes or they may be alkynes. Here, in the case of cyclic closed chain compounds, they are also classified into two types based on the atom presence in the ring. They may be carbocyclic or homocyclic. They may be heterocyclic. In carbocyclic, they contain only carbon atoms. These carbocyclic further classified into two types. They may be alicyclic or they may be aromatic. Alicyclic compounds means they have cyclic compounds, cyclic structures, and shows aliphatic nature. In the case of aromatic compound, they further classified into two types. They may be benzenoid compounds or they may be non-benzenoid compounds. In the case of benzenoid compounds, they contains benzene rings, benzene, naphthalene, etc. In the case of non-benzenoids, they don't contain benzene rings but shows aromaticity. Okay, this is all about the classification of hydrocarbons. Okay, fine. Next, here our main topic is heterocyclic compound. So there is also classification for heterocyclic compound, that is classification of heterocyclic compounds or heterocycles. Here generally heterocyclic compounds classified based on two parameters. The first parameter is based on number of rings or based on the ring nature. Based on the number of rings present in a heterocycle compound, there may be two types. Here, based on the ring structure or number of rings, the heterocyclic may be two types. They may be monocyclic compounds. These monocyclic compounds also known as simple heterocyclic compounds. Here, in the case of monocyclic or simple heterocyclic compounds, they contains a single ring structure with one or more than one heteroatoms. They may contain one or more than one heteroatoms. Here, the simple heterocyclic compounds may be here 5-membered, 6-membered, or they may be sometimes 3-membered, or they may be 4-membered rings based on the ring size. They may be 3-membered ring, they may be 4-membered, 5-membered, 6-membered, or sometimes they may be 7-membered ring. Here, this generally known as simple heterocyclic compounds. Here, example for 5-membered and 6-membered rings are here. The first one is example for 5-membered heterocyclic compounds with one heteroatom. The first one is furan. The second one is ferrol. This one, third one is thiophene. All these are example for 5-membered one heteroatom heterocyclic compounds. Here the below one is pyrazole, oxazole, imidazole. These three compounds are also examples for 5-membered heterocycles with two heteroatoms. Here in the right side, the examples are example for 6-membered rings. It is pyridine. First one is pyridine. It is 4H pyran, 4H pyran, 2H pyran. It is pyrimidine. It is pyrazine. It is pyrazine. Sorry, it is pyrimidine. It is pyrazine. It is piperidine. It is pyrazine. It is pyroxazine. Okay, these all examples for 6-membered heterocyclics. Okay, fine. Next, heterocyclic compounds classified two types based on two parameters. One, the first parameter is based on the ring structure or number of rings. The second one is here based on the ring structure. They classified into further two types. One is monocyclic compounds or simple heterocyclic compounds. The second one is fused or condensed heterocyclic compounds. That is based on the ring type. They classified into two types: simple heterocyclics or monocyclic compounds. Second one is fused or condensed heterocyclic compounds. Here in the condensed heterocyclic compounds, two or more than two rings are fused together. If you observe the example for fused rings or fused heterocycles, here there are some examples, that is furin, adenine, guanine. Here these three fused heterocyclic or condensed heterocyclic compounds are generally example for DNA bases. These are furin, adenine, guanine, or these are DNA bases. These are generally pyrimidine and imidazole, pyrimidine and imidazole rings, which due to the fusion of the pyrimidine and imidazole rings, we get this DNA bases. This is first one is pyrimidine. The second part is imidazole. Due to the fission of pyrimidine and imidazole, we get DNA bases, that is furin, adenine, guanine. The second one is here benzene fused rings. Here these compounds are generally, all these compounds are contains one benzene ring along with the one heterocycle. Here the first one is 1H indole, that is the nitrogen atom is saturated, so it is 1H indole. Here it is quinoline, it is isoquinoline. These are example for condensed heterocyclic compound. Condensed heterocyclic compounds may condensed by two heterocyclic compounds, or they may condensed by one benzene ring and one heterocyclic compounds. The first one is heterocyclic fused rings. The second one is benzene fused rings. Okay, fine. Next, the second parameter for classification of heterocycles is based on their aromatic character. The first one is based on the ring structure or based on the rings. They may be monocyclic or simple heterocycles, or they may be condensed heterocycles. The second classification is based on the character, aromatic character of the heterocycle. Based on the aromatic character, that is whether they shows aromaticity or whether they don't show aromatic character, they classified into two types. If they shows aromatic character, those called as aromatic heterocycles. If they don't show aromatic character, they known as non-aromatic compounds. The case of aromatic compounds, these have planar structure, conjugated pi bonds, as well as they obeys Ockel's 4n plus 2 5 electron rule. If you observe the examples for aromatic heterocyclic compounds, they may be furan, thiophene, firrol, sorry, here is L, firrol, pyridine, indole, benzofuran, quinoline, isoquinoline, carbazole. All these are examples for aromatic heterocycles. Okay, fine. Next, the second one is non-aromatic heterocyclic. That is, they don't show aromaticity or they don't have aromatic character. These are these are known as non-aromatic compounds. Though they contain some planarity, they don't obey Huckel's 4n plus 2 5 electron rule. So there are many examples for non-aromatic compounds. For example, they may be oxirane, thyrane, aziridine, oxetane, thioetane, agitidine, tetrahydrofuran, ferrolidine, piperidine. All these are saturated compounds of aromatic heterocycles. These are generally, they don't show any aromatic nature. Example for non-aromatic compounds. There are also some non-aromatic compounds with partial double bonds. They may contain partial double bonds, but they don't obey Huckel's 4n plus 2 5 electron rule. For example, dihydrofuran, dihydrothiophene, dihydroferrol, or dihydropyridine, like that. They are partial unsaturated aromatic, non-aromatic compounds. Okay, fine. This is all about classification of aromatic compounds. That is classification of heterocyclic compounds. Heterocyclic compounds based on two parameters. One is based on the ring structure, whether they may be monocycle compounds or they may be fused or condensed heterocycles. The second one is based on the aromatic character. They may be aromatic heterocycles or they may be non-aromatic heterocyclic. Okay, fine. Next, next one is nomenclature of heterocyclic compounds. In order to name any given organic compounds, generally there are two systems. One is common system or trivial names. Second one is IUPAC systems or IUPAC names. In order to name heterocyclic compounds according to IUPAC nomenclature, first of all we should find out the heteroatom in a given heterocyclic. Then we have to give numbers to the heterocyclic compound according to Arabic numerals or according to Greek letters such as alpha, beta, gamma, delta. After finding heteroatoms in the given heterocycle, we have to give numbers to the ring, heterocycle ring, in order to get least number to the heteroatom. Generally, here the numbering generally follows anti-clockwise direction. In many cases, the case of heterocyclic compounds, we should give numbers to the heterocycle in anti-clockwise manner according to Arabic numerals or according to Greek letters such as alpha, comma, beta, or delta, anyone. Here, if the heterocyclic compound contains more than one heteroatom, then we should give numbers to the heteroatoms based on their priority order. There is some priority order. For example, the order is if the compound contains oxygen, sulfur, nitrogen, or phosphorus, the order is we should give first priority to oxygen, next to sulfur, next nitrogen, next to phosphorus. This is priority order of different heteroatoms in heterocyclics. After identifying heteroatoms and numbering, we should follow a specific order to give a particular name according to IUPAC system to that particular heteroatom. The order of IUPAC system is the order contains prefix, stem, and suffix. That is, it contains three parts. First one is prefix, and the middle part is stem. The last one is suffix. What is the prefix? Here, the prefix generally indicates the heteroatom or heteroatoms present in the heterocycle along with their number and their positions. Prefix generally indicates nature of heteroatom along with its number and position. We have to give a specific name to the heteroatom present in the heterocyclic as a prefix. For example, if there is oxygen heteroatom, then we should give as, or we should name it as oxa. If it contains sulfur, we should name it as thia. Sorry, it is thia, not s. Thia. If it contains nitrogen atom, then we should name it as aja. If there is phosphorus, the prefix is phosphor. If there is, sorry, it is b, not n, it is boron. If there is b, boron, then it is bora. Okay. Next, what is stem? Generally, stem indicates ring size. Stem indicates a ring size, whether it is 3-member ring or 4-member ring or 5-member or 6-member, or it may be 7-membered ring. Based on the ring size, we have to give a specific stem to that particular heterocycle. If it is 3-membered ring, the stem is air. We should it is 4-membered ring, the stem is et. 5-membered, it is whole. If it is 6-membered, the stem is ein or in. That is, based on the ring size, we should give specific stem to in order to name that particular heterocyclic. 3-member air stem, 4-member et, 5-member ol, 6-membered in or ein. Okay, last one, suffix. What is suffix? Here generally suffix indicates whether the heterocyclic cyclic compound is saturated or unsaturated. It gives information about the saturation or unsaturation of heterocycle. Here the saturation or unsaturation generally depends on the presence or absence of nitrogen heteroatom in the ring. Generally depends on the presence or absence of nitrogen atom in the ring. Okay, this is the rules we should follow in order to name a particular heterocyclic compound. Okay, fine. Next, here, so that these are the tables indicate the rules for nomenclature of the heterocyclic compounds. The first table generally it gives information about the prefix in order to name a heterocyclic compound. Here the heteroatom may be oxygen, sulfur, selenium, nitrogen, phosphorus, silicon, boron, mercury, whatever it may be. If the heteroatom is oxygen, then the prefix name is oxo. It gets first priority. Oxygen gets first priority. If there is sulfur, it is the prefix name is thia. The order is second. If there is selenium, the name prefix name is selena. It gets third priority. If there is nitrogen, the prefix name is aja. It gets fourth priority. There is phosphorus, the prefix name is phosphor. It gets fifth priority. If there is silicon, the prefix name is sila. It gets sixth priority. If there is boron atom, the prefix name is bora and gets seventh priority. There is mercury, mercura, prefix name, and the order of priority is it is eighth priority. Okay, the first table gives information about the prefix as well as order of the heteroatom in the heterocyclic cycle. Okay, the next table gives information about the stem. That is, stem gives information about the ring size. Here, if the ring size is third, that is 3-membered ring, the stem is air. That try. If the ring size is 4, then it is 8. If ring size is 5, then we should give whole stem. If ring size is 6, then it is iron. Okay, the last table generally gives information about the suffix. That is, suffix gives information about the whether it is saturation or unsaturation of the heterocycle. Generally here saturation and unsaturation depends on the presence or absence of nitro atoms. Okay, rings, if the heterocycle is 3-membered ring, then stem is air. Here the final name, that is stem plus suffix, stem plus suffix per nitrogen present. If there is nitrogen present and the cycle is unsaturated compound, then the total, that is stem plus suffix, becomes as iron. If the compound contains nitrogen atom and it is saturated, then stem plus suffix become as iridine. Iridine. If the heterocycle is 3-membered ring and it don't have any nitrogen atom, then in the case of unsaturation, then it is iron. If it is saturated, we should name it as iron. That is iron, stem plus suffix. If it is 4-membered heterocyclic, then stem is 8. But if the compound contains nitrogen atom and it is unsaturated compound, then the stem plus suffix become ate. If it is saturated along with nitrogen atoms, then it becomes etidine. If the compound don't have nitrogen atom, but it is unsaturated four-member cycle, then stem plus suffix became ate. Then it is saturated without nitrogen atom, then stem plus suffix became ethane. In the case of five-member ring, it is stem is whole. Then the compound contains nitrogen atom as well as it is unsaturated compound. Then the stem plus suffix become whole. Then if it is saturated, then olidine. Then the compound is five-membered ring and it don't have any nitrogen atom and it is unsaturated compound. Then it is whole, that is stem plus suffix for unsaturated five-membered ring without nitrogen atom is whole. If without nitrogen atom but it is saturated, it is whole in. Okay. In the case of six-membered ring, it is stem is iron. Then the compound is unsaturated compound with nitrogen atom. Then the stem plus suffix become iron. Then in the case of six-membered rings with nitrogen atom and saturation, then it is simply a stem plus suffix becomes a. If the compound is six-membered and unsaturated compound without any nitrogen atom, then it is in. If it is saturated, it is in. Okay, we should follow these rules in the case of 7, 8, 9, 10 member rings heterocycles, whether they contains nitrogen atom or whether they don't have nitrogen atoms, based on the saturation and unsaturation in the ring. Okay, this is all about the rules we should follow in order to name a particular heterocyclic compound. Okay, fine. Next, if the heterocyclic compound is partially saturated compound, the compound is partially saturated, then we should add dihydric, sorry, dihydro, it is not dihydric, dihydro or tetrahydro prefixes along with the saturated position before the name of that particular heterocyclic compound. That is, in order to name heterocyclic compound, that is partially saturated heterocyclic compound, we should add dihydro, tetrahydro prefixes along with their position before the name of that particular heterocyclic compound. In the case of next, in the case of carbocyclic fused rings, that is, in the case of fused heterocyclic or condensed heterocyclic compounds, condensed heterocyclic compounds are two types. They may be carbocyclic fused heterocyclic compounds or they may be heterocyclic fused compounds. That is, in the case of carbocyclic compounds, one ring must be benzene ring. So here in the case of carbocyclic fused heterocyclic compounds, we should name the carbocyclic ring or the benzene ring before the name of heterocyclic or heterocyclic ring as a prefix. That is, in the case of carbocyclic fused compounds, the carbocyclic name added as a prefix before the name of heterocyclic ring. In the case of arenes, we should name it as arrow as a sub prefix before the name of heterocyclic compound. For example, In the case of benzene fused compounds, that is, the heterocyclic compound is fused with benzene ring, then we should add, sorry for the disturbance. Sorry. If the carbocyclic compound, in the case of carbocyclic fused rings, if the carbocyclic ring is benzene, then we should add benzo as a prefix before the name of that particular heterocyclic compound. If there is naphthalene, then we should add naphtho as a prefix before the heterocyclic compound name. Okay. In the case of heterocyclic fused heterocyclic compounds, that is, if the heterocyclic condensed heterocyclic compound fused with other heterocyclic compound, then we should add lower priority, or we should add the name of lower priority heterocycle before the higher priority cycle name as a prefix. That is, if the condensed heterocycle contains two heterocyclic rings, then we should prioritize the two rings. After prioritizing, we should add the name of lower priority heterocyclic compound as a prefix before the name of high priority heterocyclic compound name. Okay, this is all about the nomenclature of heterocyclic compounds, whether it is single or simple heterocyclic compound, or it may be partially saturated heterocyclic compound, or it may be condensed heterocyclic compounds. Okay, based on the specific rules, we should name the given heterocyclic compound. Okay, fine. Next, here there are some examples in order to name a particular heterocyclic compound. If you observe the numbering to a heterocyclic compound, here the first one is, it is furan. Here it is oxygen containing 5-member heterocyclic compound. Here heteroatom is oxygen, so we should give first number to the oxygen atom. Then we should give the numbers in a anti-clockwise. So it gets first number, it is second, third, fourth, fifth, according to Arabic numerals. If you give numbers according to Greek letters, then the carbon adjacent to heteroatom gets alpha position. That is, it is alpha. The second one is beta. Here in the left side odds same as in the case of right side. So they simply gets alpha dash, beta dash. Here also in the case of pyrrole, the second, sorry, it is pyrrolidine. It is 1, 2, 3, 4, 5, or alpha beta, alpha dash, beta dash. It is pyridine. The third one is pyridine structure. Here the pyridine contains nitrogen heteroatom, so it gets nitrogen gets first priority, first number. Then the other atoms according to anti-clockwise direction, 2, 3, 4, 5, 6, or the carbon atom adjacent to nitrogen atom gets alpha according to Greek letter. The second one is beta, the third one is gamma. Here in the left side it gets alpha dash, it gets beta dash. In the case of next compound, it is quinoline. It is quinoline. Here the nitrogen gets first priority, next second, third, fourth, fifth, sixth, seventh, eighth. These two positions indicates fused positions. We don't give numbers to the fused positions. Okay, this is all about the nomenclature of heterocyclic compounds. Okay, fine. no sorry next, there are so many examples in order to name according to IUPAC nomenclature. Here the compounds are examples for heterocyclic compounds with IUPAC names. Here it is first two or three membered heterocyclic compounds according to IUPAC nomenclature. It is oxirane. The blue color indicates IUPAC nomenclature. The black color indicates trivial names. Ethylene epoxide. It is according to IUPAC it is oxirane. The second one is ethylene imine, but according to IUPAC it is aziridine. This third one is oxetane. It is oxole. Furan, general name is furan, but IUPAC name is oxole. It is tetrahydrofuran, trivial name, but IUPAC name is oxolane. This one is thiopine, general name, but it is thiol according to IUPAC. It is pyrrole, general name, but it is according to IUPAC it is 1H azole. It is pyrrolidine, common name, but IUPAC name is azolidine, sorry. It is pyron, general name, but 2H pyron, IUPAC name. It is pyridine. It is uh, agine. IUPAC name is here for this pyridine. The IUPAC name is agine. AZDAIN, agine. Here it is piperidine. IUPAC name is perhydropyridine. It is imidazole or 1,3 diazole. Thiazole. IUPAC name is 1,3 thiazole. Dioxane, but IUPAC name is 1,4 dioxane. It is marpolin, general name, but it is tetrahydro 1,4 oxazine. It is pyrimidine, but the IUPAC name is 1,3 diazine. It is indole, general name, but IUPAC name is 2,3 benzoferrol. It is isoindole. It is indoligine. It is okay. Look at all these atoms according to trivial and IUPAC names. These are examples for some IUPAC names of heterocyclic compounds. Okay, next, here also some compounds, that is partially saturated, example for partially saturated, as well as some fused heterocyclic compounds. Here it is one saturated at 1 and 2 position, so it is 1,2 dihydroagine. Here the compound is saturated at 1 and 4th position, so it is 1,4 dihydroagine. It is saturated at 2, 3 and 4, 5. 2, 3, 4, 5. So it is 2, 3, so not 4, 2, 3, 5, 2, 3, 2, 3, 4, 5, not 5, 6. It is 2, 3, 4, 5 tetrahydroagine. Here it is saturated at 2nd position, so it is 2H oxine or 2H furan. These three compounds, that is these three compounds generally saturated at single position. Here it is at 2nd position, so it is 2H furan. It is saturated at 2 position, so it is 2H 1,4 thiazine. It is saturated at 4th position, so it is 4H furan. In the case of single saturated compounds, we should mention the position of saturation along with the hydrogen. Okay, these compounds are example for condensed heterocyclic compounds. They may be carbocyclic or they may be heterocyclic compounds. The first three are example for carbocyclic or benzo fused heterocyclic compound. These are examples for pyrazine fused heterocyclic compounds. Here one ring pyrogen, the other one is different one. Okay, go through all these examples for IUPAC nomenclature. Okay, fine. Next. Thank you very much for your patience for watching this video. Thank you one and all. Bye.